All right, so the side that we will take notes on is the properties of definite integrals side, and then we'll be able to flip it over and do the homework on the reverse side. Even before we get into those properties, let's do a quick little picture up here, just to kind of remind ourselves what is going on. So I'm going to draw some kind of random graph. It doesn't really matter what it looks like. I'm going to put 3 x values on there, a, b, and c. And so that area, be careful, try not to get into this line because we're going to need that line for notes in a minute. But that area would be the integral from a to b of f of x dx. Right? Again, that's just making sure we understand that this symbol, this notation, means the area. And if we wanted to do from b to c, that area would be from b to c of f of x dx. Does that make sense? We're good with that? We've seen that before, done that before. That was yesterday. Okay. If you get that much, I think most of these properties are going to make sense. So this first one, the integral from a to b of f of x plus g of x. Well, so we're sort of stacking these functions on top of each other. So if we had f and had g and put them on top of each other, that would add their area. So we can go a to b of f of x plus a to b of g of x. So we can split up an integral because areas add. And it makes sense that if you could add them, you could also subtract them. Because adding and subtracting are kind of the same. I mean, they're opposites, but in some ways, mathematically, it's the same thing. I have a teacher that lives next to me. She teaches 5th grade. I'm pleading with her to stop teaching PEMDAS because then students do addition before subtraction rather than realizing that they're the same thing. So that's a little side note there, but elementary education. Part C, integral from a to b, k, so there's a multiplier on there. So think about this picture. If I had this integral from a to b of f of x, if I multiplied the function by 2, what would that do to the area? I mean, go with the obvious answer here. It would double it. Like it would get twice as high, so it'd be twice as much area. So that means I can slide the k out front. For property D, look very, very carefully at what's written there. That's not a mistake. If you catch it, something doesn't look quite right.
This goes from A to A.
Right? And so what's the area under the curve from A to A? 0. There's no area there. It's like if we did width times height, well, it doesn't matter what the height is. If the width is 0, then it doesn't matter what the height is. So be very careful as you're working these problems. If they sneak one of these on you, that's an easy one because you haven't gone anywhere. That area is 0. With a note, you do have to have a function there. If you don't have a function, then you couldn't answer the question. Part E, or property E. The integral from How is this one different than all the other ones?
B to A.
B to A. That feels backwards. What usually happens in math class or physics class if something is backwards? What's that lead to? Negative. And it means the same thing here. So that's negative integral from A to B. That's a little bit weird. So that means that our area has to be, if we're moving from left to right, it's a positive area. Now there's really no such thing as a negative area, but if we write this to go backwards, then whatever area that is, we would say the integral is negative, even though negative area is a little bit kind of a fishy thing to say. So if you go backwards, it's negative. One more property that I was going to put where I put that picture. So let's put it, maybe one of these days I'll update this and have it nice and neat. But the integral from A to C, f of x dx, and this one goes with our picture. Well, if I broke that up, I could go from A to B and from B to C. I need to write the rest of the stuff in there, but that's the point we're looking at. If I go from A to B and then from B to C, that's the same thing as if I had just gone from A to C to begin with. So looking at limits of integrals, this is not a hard property if you're thinking about the picture. A to C means all of the area. A to B would be the first piece. B to C would be the second piece. So you add the two areas, you get the full area. All right, some sample problems here. The area under sine of x from pi to pi. 0. Because I don't, it's from pi to pi. Like if it was from 0 to pi, I don't know what the answer would be. But from pi to pi, that's a 0 width rectangle or a 0 width area, so there is no area there. Evaluate this integral if this integral is 21 halves. Negative 21 halves. Because all we did was switch the limits around, so that made it negative. Negative 21 halves. Now, soon enough, later next week, we'll be able to evaluate this without knowing that, but we're not there yet. So one piece at a time. All right, the stuff down here, it gives you a bunch and then asks you to use it. So make sure you recognize that there's some given information here, because we don't know yet how to evaluate these integrals without that information. So the integral from 1 to 3 of negative x squared. Well, that looks a lot like this one. What's the answer going to be? Negative 26 over 3. Because I can pull the negative out front, and then what's left is 26 over 3. D, the integral from 1 to 3, okay, they're all 1 to 3, 4x dx. Well, I've got an integral of x dx. So if I take that 4 outside, and then it tells me what that is equal to, that's 4. So my answer is 16. Again, this is more of a concept day than a doing calculus day, calculus methods. I mean, the math that we're doing is adding and subtracting and putting negatives on there and multiplying by 4. Like, this is not difficult math-wise, but it's important concept calculus to understand what's going on. Right, part E looks most like that last one, except there's a negative 3 on there, but we can take a multiplier and move it out front. So negative 3 integral of dx by the way, if you can, save some room at the bottom. We're going to throw some more notes down there. So that's negative 3 times 2, negative 6. Let's see, part F kind of puts them all together. Let's see, negative x squared. And by the way, if you're really paying attention, the first one is problem C, the second one's problem D, and the third one's problem E. So we've already done all the pieces to this. I don't know how many times I worked this worksheet before I realized that. It was probably a student that pointed it out. So negative x squared, we already have that answer. 4x, we have that answer. Minus 3, we have that answer. And safe stop, we're done. Like, I don't know why, especially with the 3 in there, why risk messing anything up? Be done with that. All right, a few lines of not provided notes here. If the integral from 0 to 3 of f of x dx equals 4, and the integral from 3 to 6 of f of x dx equals negative 1, find, so it's sort of like what we just did. Here's some, we're going to give you a couple, and then we're going to tweak them and see if we can figure out what the answers are. Let's find the integral from 0 to 6 of f of x dx. So look at what you got. Think about what each piece represents. The area from 0 to 3, the area from 3 to 6. I want the area from 0 to 6. So what's my answer going to be? 3. Because from 0 to 3 is 4, and from 3 to 6 is negative 1. So my answer is 3. About the integral from 6 to 3 of f of x dx? 1. So from 3 to 6 is negative 1, but that means if we go backwards, we're now negative, negative, we're back to a positive 1. If f is even, then find the integral from negative 3 to 3 of f of x dx. F is even. What does even mean? In terms of the graph, in terms of symmetry. Anybody remember what an even function looks like?
X squared.
Okay, x squared is an example of an even function. What makes it even?
Oh, it's something about the y-axis.
It's something about the y-axis. More specifically,
Symmetrical.
it's symmetric with the y-axis. So let's draw just a make-believe function here. From 0 to 3, I don't know what it looks like. But that area is supposedly 4. A lot of times we'll label the area like just by writing it on the area and circling it. That's just sort of the kind of a standard shortcut to say that area is 4. So if this was f and it's an even function, that means it was does the same thing on the other side. My picture is not perfect, but if this function mirrors this function, then what's the area under here on this side? It's got to be 4 as well. So then my area from -3 to 3, we'll just make that part of the answer, would be 8 because of the reflection thing. Alright, now let's answer the same question if f is odd. If f is odd, -3 to 3. You remember what an odd function looks like? Or an example of an odd function? X cubed is odd. What makes it odd? Or what does the odd symmetry look like? Well, not that.
Like this one, right?
Okay, like that one. If you... like that? Yeah, you could write it like that. That would be an odd function. So let's say... I have to go far enough to catch all this. Let's say this area is this combined area, although... this is odd. It's more complicated than I want to make it, though. Let's make it something like that. Because I want my area from 0 to 3 needs to be 4. It needs to be positive. All right, so this is a little bit of a new concept here. If this area is 4, this area is 4, but because it's below the axis, it's negative. Okay? So area below the axis is negative. It's also negative if you go backwards. So you got to be careful. There's a couple things that can make it negative. You can go backwards and get negative, or you can be below the axis and be negative. So if I add up the area from -3 to 3, what's the total area? Be careful. I mean, I guess the total area is 8 if we're talking strictly about area, but the integral is 0 because we count that as a negative area. If it's below the axis, it's a negative area. If we go backwards, it's a negative area. And then, well, I need to do one more thing. Sorry, I hope you've left room somewhere there to... That's what happens when I try to wing it. I don't want it to do that. I wanted it to be below the axis. So let's say that shaded area, the actual area is 13. But if I want the integral from 5 to 2 of that function, what do we think that answer is? Why? It is 13. Why isn't it negative?
Oh, because it's underneath
Right, it's like it's negative twice. It's below the axis, so that makes it negative. But 5 to 2 is negative, so it's sort of negative 13, which would just be 13. So this is really the only thing that messes people up on this whole unit, because this isn't really hard. And you can keep straight that if I go backwards, that's negative. Okay, if I'm upside down, that's negative. But I just need to be real careful if both things are happening. Two negatives still make a positive. Macy.
So, for the last example we did, was it 0 because the longest one 4 came through?
Yes.
Okay.
Because this side was 4, and this area was 4, but the integral was negative 4 because it's below. So be careful when we say area. Sometimes I'll say area is negative. That's not technically correct. The area is always positive, but the integral might be negative if it's below or if it's backwards. So good questions, and I need to be careful about the words, or we all need to be careful about the words we use with negatives. All right, so the assignment is on the reverse side. It's kind of the same stuff we were just doing using properties. So this is not a difficult assignment. This is another one that you can finish before you leave.